Hey, hi everyone. Welcome back to my YouTube channel. My name is Sunny and I'm back with another exciting and important video. So guys, from this video onwards, we're gonna start the fine tuning of the large language model. As you know, I started one end-to-end LLM fine-tuning playlist where I uploaded 13th video so far. In the last video, I discussed about the LLM quantization. And apart from that, I discuss each and every fundamental concept of the fine-tuning. Now it's time to deep dive into the LLM fine-tuning. I will show you the practical with respect to each and every framework. So today I'm going to start with the Hugging Face ecosystem. In the next video, you will find out axolotl, then onslaught, the llama factory, and you will find out fine tuning of different model, not only the text model, even I will fine tune the multi-model which can handle the images and other different type of data. So guys, if you haven't checked with this particular series, please go and check. And if you want to start this fine tuning, then you can start from this particular playlist itself. Now apart from that, I have uploaded so many other thing on my YouTube channel. If you are new to my channel, then please go and check inside this video section, or else inside this playlist section you will find out different video of the different concept. If you want to start your generative AI journey, then you can start from this particular playlist. Now guys, let's begin with the LLM fine tuning. First of all, I will tell you the agenda, that what all thing we are going to discuss. Okay, and then step by step, one by one, we'll understand along with the example, and then we'll go with the practical. So guys, here I will show you the fine tuning of the LLM in that way only, like they have fine tuned the GPT model. So we'll take any raw model, we'll understand about the non-instructional fine tuning, then we'll understand about the instruction fine tuning, then we'll go with the preference alignment. Okay, each and everything step by step we'll try to discuss. We'll fine tune on top of the PDF data, on top of the TXT file. We are not going to fine tune directly on the instruction and the responses, means on the input and the output. No, not like that. I will go step by step. I'll pick up one model. I will basically first fine tune it on a domain specific data. Okay, the data can reside anywhere, right? In PDF, text, PPT, docs, anywhere, right? And after that only we'll come to the instruction fine tuning on a same model, and then we'll go with the preference alignment. Okay, so this video, this 3 to 4 video upcoming videos also is going to be very important. And yeah, so if you haven't subscribed my YouTube channel, please subscribe the YouTube channel and start your generative AI journey. Now let's start with the fine tuning of the large language model, guys. So guys, before starting with the LLM fine tuning, we'll have to understand the training pipeline of the large language model. So first, we'll take a walkthrough of the LLM training pipeline along with the example, and then only I will come to the fine tuning. Okay, the practical and all. So guys, if we're talking about the LLM, so we can choose any LLM. Let's suppose if I am showing you the fine tuning with the Llama, you can choose any other LLM. Okay, the code base would be similar. You just need to change the model ID. Okay, or from wherever we are going to pick the model, you just need to pick the any other model, any other different model. Okay, according to your requirement. Now guys, so if we're talking about the LLM training pipeline, so there is 3 stage. The very first stage is called the unsupervised pre-training. Unsupervised pre-training. Now this is also called self-supervised learning. Okay, self-supervised learning. Now the second stage is called SFT. Okay, this is very much important. SFT. Now what's the full form of this SFT? It is called supervised fine tuning. Okay. Now, if we're talking about the supervised fine tuning, so on a data level, on a parameter level, we can divide into two parts. The first is called, so let me write over here on parameter level. Okay. So on parameter level, we can divide into two parts. The first is called full fine tuning. Okay. And the second is called partial fine tuning. Second is called, guys, let me write over here, partial fine tuning. So we're talking about the full fine tuning. Now here we are going to train all the parameter. Okay. So if we are talking about this full fine tuning, so we are going to train all the parameter. Now if we're talking about the parameter, guys, so parameter is nothing, it is weight and the biases. Okay. Now guys, whenever we're talking about the full fine tuning, so this full fine tuning, okay, full supervised fine tuning, it is required more memory. Okay, it's required huge GPU memory. Okay, and it's required multi GPU setup also. Multi GPU setup if the data is very huge. Okay, if the data is very huge, if the model is very huge, in that case it will be required the multi GPU setup. So we avoid this full fine tuning. Now the second technique is called the partial fine tuning. Okay, so let's understand about it. So we're talking about the partial fine tuning. So again, there is two method. Okay, two method of it. So one is old school method. Old school method. Now inside this old school method, what we are doing, so we are just going to be freeze all layer and train last output layer. Okay, train last output layer. Now the second one, what we can do now here, freeze some starting layer, and retrain. Okay, so here it's not train, it's a retrain. Okay, now here is also retrain some last layer. Okay, so this a particular technique generally we followed in the CNN based architecture, right? CNN based model, or in a early stage LLM also. So in the early stage LLM, like, let me write over here, early stage LLM like bot. Okay, bot T5, right? T5 or BART. So this was the early stage LLM. So inside these particular model, we have followed this technique, right? But in a large language model, whatever large language model we are seeing. See guys, now one more thing. If I'm saying large language model, now what does it mean? So large language model means the model which was built on top of the transformer. Okay, so all the large language model are following this transformer architecture in backend. Okay, if you don't know about the transformer, guys, soon I will create one video on top of it, and for sure you will understand. Now guys, the second technique, okay, which is not an old school technique, which is a latest technique, so that is called, let me write over here, PEFT. Okay, PEFT, P-E-F-T. Now what does it mean? PEFT means, PEFT is called parameter efficient fine tuning. Okay, parameter efficient fine tuning. Now inside this parameter efficient fine tuning, we are not going to be train all the parameter of the model. Instead of that, we are going to be train some specific parameter, right? So let me write couple of techniques name over here, and in the future we'll discuss in a detail. Now guys, let me write one very popular name under this PEFT, which is called LoRA. Okay, I think you heard about this LoRA, right? So we have one quantized version of the LoRA. If we are going to be use the quantized model, so which is that is called QLoRA. Okay, now this Q is representing to the quantization. Okay, this Q is representing to the quantization. Now why we do the quantization, what we do in the quantization, you can check out with my previous video. So let me highlight some points over here. So in the quantized model, we use the lower precision model. Now what is the lower precision? Okay, each and everything I shown inside that particular video in the previous video, you can check out over there. Now this quantized model is a memory efficient model. Okay, so using this quantized model, we can do the memory efficient loading. Okay, so quantized model is the lowest precision model. If it is a lower precision model, then we can simply load into the memory. Okay, we can do the memory efficient loading and all. So that's a benefit of the quantized model. So LoRA is one of the technique. Okay, and if we can extend, right, if we are going to be use the quantized model, so that is called the QLoRA. Now if we're talking about the PEFT, guys. Okay, so this PEFT, right, this parameter efficient fine tuning, this might work on a single GPU as well, right? So here I can write this PEFT technique, this might work with single GPU and smaller VRAM. Okay, now guys, this LoRA is not one and only the technique. Okay, we have some other technique also. So let me write the name of those specific technique, right, which I found apart from this LoRA, and definitely in this fine tuning series we are going to discuss that. So the second technique, which is called DORA. Okay, I'll come to this DORA. Maybe many of you hear this name first time. The second technique is called, the third technique is called the adapter. Okay, adapter layers. So adapter layers is also inspired from the LoRA only. We are going to be append some layer, okay, in the existing block of the transformer. Okay, so which is called the adapter layer. So DORA and the adapter layer is also a couple of techniques, okay, which we can use instead of the LoRA. Now we have some other technique. So let me write the fourth name over here, which is called the bit fit. Okay, bit fit. So this is also parameter efficient fine tuning, and it is getting very popular, and I'll show you the research paper of it. Now the fifth technique, which is IA3. Okay, I'll show you what is this IA3. This is also parameter efficient fine tuning. Now apart from that, let me write a couple of more names. So prefix tuning, it's also one more technique. For sure I'll show you this also. Okay, then the next is prompt tuning. Okay, prompt tuning. Prompt tuning, it might not be a part of the PEFT, but yeah, I kept it over here, and I'll show you the use of this prompt tuning as well. But guys, this LoRA is not one and only PEFT technique, which is parameter efficient fine tuning, where we are not going to be training the entire parameter of the model. Parameter means what? Weights and biases. Okay, instead of that, we are going to train only couple of parameter, or only subset of parameters. So LoRA, DORA, adapter layers, bit fit, IA3, prefix tuning, these are some technique, these are some PEFT technique, and for sure in our fine tuning playlist we are going to discuss all these technique. Okay, now let me show you the research paper of it. So if you're talking about the IA3, so guys, here you can see the very good blog on this IA3 over the Hugging Face itself. So the full form of this IA3 is infused adapter by inhibiting and amplifying inner activation. So the name seems very complicated, guys, but yeah, we can implement it by program, by the code and all, and that will not be very difficult. So it is a part of the LoRa itself. To improve the LoRa, actually we use this IA3, and it is a part of the PEPT. So that's why I kept under the PEPT itself, because we are using it to improve the LoRa itself. Yes, for sure, LoRa is very important, and the base for everything is the LoRa, LoRA. Okay, now here guys, you can see the research paper of it. You can check out the research paper. Even I'll show you that when I will discuss it, this is specifically this IA3 and all. Now here is a bitfit, guys. See, this is the research paper of the bitfit, simple parameter efficient fine tuning for the transform based mass language model. Okay, so we can use this bitfit also. Again, this is not very popular, but yeah, we can look into it. If you are doing some experiment, you can go through with it. Otherwise you can do everything from the LoRa, from the IA3, from the DORA, and the this one. Basically one more is there. Let me show you. So here is a DORA, guys, right? So what is the full form of the DORA? Weight decomposition low rank adaptation, right? So this is the form of the LoRa itself. Now here again, it's a LoRa, low rank adaptation for the large language model, right? So let me highlight the points now. Let me summarize all the things. If we're talking about the partial fine tuning, we are just taking subset of the parameter. Let me mention over here, subset of the parameter. Okay, subset of all parameter. Okay, so these are a couple of technique. First is LoRa. If we are taking quantized model over there, then it's called QLoRA. Then DORA, then adapter layers. Yes, this was the technique, adapter layer. Bitfit, we can avoid this as well, but yeah, IA3 we can pick up this. Prefix tuning, it is also important. Okay, I'll come to this, I'll show you that. Prompt tuning is also again one of the technique. Okay, now this was based on the parameter, on a parameter level. Now guys, if we're talking about on a data level, so let me talk about the data level as well, and for sure I'll discuss that. Okay, so here I'm going to write on data level, on data level. So on data level, guys, we can divide into two parts based on the data preparation. If I'm saying data level means what? Based on the data preparation. Okay, data preparation. The first is called non-instruction fine-tuning. Okay, non-instructional fine-tuning, and the second is called instruction fine-tuning. Right, so maybe you heard this term many times, instructional fine-tuning, but I think you were not aware about this instructional fine-tuning. Now again, this is a part of the SFT, right? So if we're talking about the SFT, right, so this is very, very, very important, guys. Right, so we can divide into two parts. First, on parameter level, again inside the parameter level, full fine tuning, where we required huge memory and the multi GPU setup, so generally we avoid it. Second is called the partial fine tuning. Again, we can divide into two methods. One is the old school method, where we are going to be freeze the layer and then we are going to be train the rest of the layer, and then we have an advanced technique, okay, which is called the PEPT. Now under the PEPT, guys, you will find out the LoRa, DORA, adapter layers, bitfit, IA3, prefix tuning, prompt tuning. Now guys, on a data level also, whenever we are going to prepare the data, right, for the fine tuning, for the supervised fine tuning, so again we can divide into the two part. First is a non-instructional fine tuning, and the second is the instruction fine tuning. So this is all about the SFT, right? Now the third term, which is called alignment with the human feedback, okay, or which is also called the preference based learning. So let me do one thing, let me cut this thing from here. This is also, I will show you, this is an example of the unsupervised learning and all. I'll show you that. First of all, let me keep it over here, this entire thing. Okay, and let me write about the RLHF. So guys, the third stage, which is called preference based, okay, alignment with the human feedback, right? Feedback. This is also called the preference based learning. Preference based learning. Okay. Now guys, here what we are doing, we are aligning the response. Okay. We are doing alignment of the responses. Now this responses actually, this particular responses is being generated from the LLM. Okay. So guys, if we're talking about this preference based learning, so there was two methods. The first is called the RLHF. Now this RLHF, the full form of this RLHF is reinforcement learning through the human feedback. Now this particular technique was based on this algorithm PPO. Now what is the full form of the PPO? Preference, proximal preference optimization. Okay, proximal preference optimization. Now this particular technique guys, okay, this PPO actually, it comes under the reinforcement learning. Okay, so that's why this is called RLHF, which was used by the OpenAI. Okay, which was used by the OpenAI for the preference based learning, right? I hope now you got it. Now the second is the popular technique, right? Now we all are using that, and even I will show you the practical of it. That is called the DPO. Now what is the full form of the DPO? The full form of the DPO is direct preference optimization. Okay, direct preference optimization. Now here guys, this is supervised learning. This is supervised learning. I'll show you the data set of it. So in the data set you will find out question, then you will find out the response. Okay, and then you will find out the feedback of the response, whether the response is positive, whether it is negative, something like this. Okay, so guys, this is the complete stage of the LLM training pipeline. So first is called the unsupervised pre-training. Now the second is called the SFT, supervised fine-tuning, and I explained the complete supervised fine-tuning graph, which is very much important for us. And the third one, okay, after training the model, after generating a response, now based on that response, again we are going to be train our model, right? That is called preference based learning, or that is also called the alignment of the responses, the LLM generated responses. Okay, now let's see a couple of examples. So here I kept the example of the pre-training, what is the objective of it, what kind of data we are using. Then I kept for the normal fine-tuning, that I kept for the instruction fine-tuning, for the RLHF and all, and what kind of technique you can use. And here I kept one more like example, okay, which is LLM wise, Llama, GPT, Mistral. Okay, the name of the LLMs basically. So first, what was the name when it was unsupervised pre-train, then while the supervised fine-tuning, then after the preference based alignment and all, right? So all the example I kept. Now let's take a look onto this. So first let's start with the pre-training, which is also called self-supervised learning. Now guys, this pre-training is also called the unsupervised pre-training or self-supervised learning. Now why it is called the unsupervised pre-training? Because in the data actually we don't have a label. And why it is called the self-supervised learning? Because the label is being created automatically. Okay, the next word itself will be the label, okay, in the data. So guys, what is the source of the data whenever we are doing this unsupervised pre-training? Now see, whatever model you are seeing, whether it's a Llama, Mistral, GPT, DeepSeek, cloud-based model like Sonnet, Opus, okay, Gemini. So this all the model initially have been trained on a very huge amount of data. Okay, now this data could be from the documentation, it could be from the research paper, this could be the common crawl data from the internet, okay, Wikipedia, encyclopedia data, books, okay, like different books, not even in English, even in the different other languages, right? Now guys, because of that, right, so see, initially actually we have to train our model on a very huge amount of data. As I given you the example of the different model, they all did this kind of training. Now this training itself is a bottleneck means because every country, every company not having this much of data, first of all, right? Now for training, okay, for training our model, if I'm saying model means transformer based model, for training the transformer based model on a very huge amount of data, we required a very huge infrastructure, huge GPU infrastructure, huge memory processor, right? So that is very money consuming and the time consuming thing. Okay, every country, every company cannot afford it. That's why many of the companies are not able to train their own specific large language model. You can see Grok, again it's from the USA, okay, Meta again from the USA, DeepSeek from the China, right? 90% model from the US itself, and it is being trained by those company which is already having the access of the entire internet data, right? So this stage is an initial stage. Now why this stage is required? Because using this unsupervised speed training or self-supervised learning, we can teach our model general knowledge. We can teach our model how it can understand the language, okay, the grammar of that language. So to develop the learning of the model, okay, to develop the core intelligence of the model, this particular stage is required. Now what is the objective? If we are talking about the technical objective, so the technical objective is next token prediction. This is called the language modeling. Okay, we are doing it on a huge amount of data, on a large scale of data. Because of this language modeling is called the large language modeling. This LLM word actually it came from here itself. Getting my point, guys, right? Now guys, here what you will get after this particular training, what you will get a base model actually, right? For example, Llama base, Mistral base, GPT base, DeepSeek, Gemini, right? Now if you want to if you want a model which can do the conversation like a human, so again you will have to do the fine tuning, the instruction fine tuning, which is the next step that comes under SFT. Okay, if you want to make your model chat enable, right, so for that you'll have to do the instruction fine tuning, right? And if you want to align your model to the based on the human feedback, then you will have to follow the third step, which is called the DPO. Okay, direct preference optimization. You will have to align the responses of the you will have to align the response of the LLM based on the human preference. Getting my point, right? So guys, here if you want to perform the pre-training, so we required this we required the data from the huge sources. Okay, in short I can say the data from the internet itself. What is the objective of it? To predict the next token. Okay, this is called the language modeling. We are doing it on a huge amount of data, which is called the large language modeling. Okay, the LLM word came from here itself. Now what is the result of it? The result basically you will get a base model. Okay, for example, Llama base, Mistral base, GPT base, DeepSeek base, Gemini base and all. I'll give you more example, don't worry. Even I can show you over the Hugging Face itself. So if you will go with the Hugging Face and if you will check with this Meta repository, so here you will find out a different model. Now see, this particular model is a base model. Okay, Llama 213B. Now on the other hand, if you will see this model, okay, Llama 7B chat. See, this model is not a base model because after performing the pre-training, again this model have been fine-tuned for the chatting, right? Now I can show you the other model. So if you will check with the Llama repository, just go with the first page. Now here check. So Meta Llama 38B instruct, right? So this model is not a base model because this model actually have been pre-trained and then it is being trained on some instruction, right? So this is also not a base model. Now likewise you can check the different model. So which is a base one, which is not a base. In the name itself you will get it. See, this model is a base model. Now why this is a base model? Because the Llama 3.18p, it has not been trained further for any instruction, for any chatting kind of stuff. Okay, so I hope you got the meaning of the base model, right? Now why we are doing it? So that we can develop the core understanding of the model in terms of the language, in terms of the grammar. Okay, we can develop the general knowledge of the model. But guys, after doing this pre-training, still my model lacks to follow the instruction, to maintain the specific tone, in whatever tone basically we want to be train our model to produce the structure answer and all. Okay, so for that only what we do, we perform the supervised fine-tuning. Now if we are doing supervised fine-tuning, guys, so as I told you, we can divide into two parts. The first is called the normal fine-tuning, this one, and the second is called the instruction fine-tuning. Okay, instruction fine-tuning. Now when we do the instruction fine-tuning, so whenever we want to convert our model into the assistant, okay, whenever we want to convert our model into the chatbot, means it can do the chats like a human. Okay, it can do the conversation. In that case we do the instruction fine-tuning, right? Now let's say we got the we have trained our data on a huge amount of data. We got a base model, right? So what we do, guys, we do the non instruction fine-tuning, which is also called the normal fine-tuning, right? And the second is the instruction fine-tuning. Okay guys, if we're talking about the ChatGPT, so ChatGPT have skipped this particular stage, this normal fine-tuning, means domain specific fine-tuning, domain adoption fine-tuning. What they have done, they have trained their model on a very huge amount of data for developing a general knowledge, and for making it enable like a human conversation. Okay, they did the instruction fine-tuning. Now they have done the instruction fine-tuning on what? They have done the instruction fine-tuning, okay, on the Reddit data, on the QLoRA data, Stack Overflow data, GitHub issues, right? Open forum, community forum, right? Where we have question and answer, right? On top of that data, they have fine-tuned the model. Okay, they have fine-tuned the model. Now guys, when this normal fine-tuning, means non-instructional fine-tuning is required, I can give you the example of it. So let's understand it over here. So let's say you have trained one model. Okay, I can take example of the Llama. Let's say you have trained one model, Llama model. So this model is a base model. Okay, I think you got to know what is a base model. Now guys, this particular model you want to train for your own domain. Let's say this is a base model. Okay, now guys, this particular model you want to train for your domain. Let's say your domain is a pharma, one pharma company, right? Let's say Sun Pharma want to train their own model. Okay, so they are not going to be train it from scratch. Okay, this pharma company, let's say Sun Pharma, they are not going to be trained from scratch. Okay, SCRATCH, right? They're not going to be trained it from scratch. What they are doing, they're just going to be take a base model. Okay, let's say Llama 13B. Okay, they are taking this particular model. They are going to be trained for the pharma domain. So they have a domain specific data. Domain is specific data. Okay, now on this domain specific data, again they will train which model? Llama 13B model. Getting my point, guys? So this particular training, see, this domain specific data, let's say this is available in PDF. Now if we're talking about the instruction fine-tuning, so in the instruction fine-tuning, the data will be available in a question and answer format. So we would be having question and answer, or you can say input and output format, or you can say like in the instruction and response format. Okay, in any of these format the data will be available. But Here the data is available in PDF. Let's say the data is available in TXT file. The data is available in any other file, okay, in any other file format. So what we'll do, so here we are not doing instruction fine tuning. Instead of that, we are picking up this data, this PDF data, TXT data, or data in any other format. This is a plain text. Okay. Now from this data itself, what we'll do, again, we'll train our base model. Okay. On top of which data? On top of this plain data. Now how the data is being prepared, I will show you that. Okay, from this plain data, I will again, what I will do, I will train my base model. And now this base model, right, Llama 13B model, this will be my domain specific model. Domain specific model. Domain specific model. Okay, now if I want to fine tune this model further for the conversation, okay, or for generating a text, the structured text and all, then I can do the instruction fine tuning. Okay, now why we can do the instruction fine tuning, why we are doing it? So that we can generate the structure output. Okay, so let's say we are asking some question to this llama, right? So it needs to be generate the answer, but here it know the domain specific knowledge, but still it is lacking to generate the structure answer. Okay, it is generating an answer, but we want to be more refined. We want a specific answer with respect to this specific question. So what I'll do, I will perform the instruction fine tuning where I would be having the data in such a way. Okay, in which way? In question and answer format, in input and output format, in instruction and the response format. I'll show you the example. With that, your understanding will be more clear. So guys, that's what I was saying. If we are talking about the supervised fine tuning, we can divide into the two parts. One, see, we have a base model. Let's say this is my base model. So we have a domain specific data. Okay, that is a plain text in PDF, TXT, or any other file format. We can take that and again we can train our model. Now this model this model have been trained on a non-instructional data. Okay, which is the plain text or something, right? Now what is the aim? What is the aim? Why we are doing it? Why we are training this model over here? So that we can basically give the domain specific knowledge to my model. Now further, if I want to generate a structure output, then what I will do, I will train my model on the question and answer data. This particular data for the domain itself, this particular data will have to prepare by myself. Okay, for the domain, ChatGPT took the Reddit data, QLoRA data, open forum data and all. But if you are in the specific, or if we are doing it for the specific organization, so this particular data will have to create by ourselves, right? And then further, what I will do after the instruction fine tuning, I will do the preference based tuning, okay, which is also called DPO or RLHF. Okay, human feedback, right? Human retraining based on the human feedback. Okay, preference based tuning or preference based alignment, anything you can say, and DPO is a technique of it, so that my model will be aligned properly in whatever way the end user want the output. I hope you are getting the entire chronology now. Okay, so guys, here you can see, if we're talking about the don't worry, I'll show the example and all. If we're talking about the normal fine tuning, okay, this is for what? This is for the domain adaptation, right? Now dataset, what? Dataset could be the plain text. Okay, it could be the company document. Now use case, making LLM domain expert, okay, in any sort of a area like medical, legal, finance, e-commerce, whatever. Now what is the goal of it? To improve the model understanding and knowledge with respect to any domain, okay, or to adapt that particular language. Now what is the output style? Produce text continuously, not necessarily capable or following instruction. Means if we are asking any question, for sure it's going to be generated text, but that text would be aligned with my question, would be the structure one. It might not be, because here again we are developing a knowledge, the domain specific knowledge of the model. Okay, meaning the model learning is the statistical distribution of the text, not question answering behavior. So again, we are not going to be train our model for such question answer. We are going to be develop the domain specific knowledge of the model. Okay, and I'll show you this thing practically. So what is the example? So example, let's say this is a text. Okay, how the data set will look like. So I kept like one paragraph over here. So Sunny Savita here, where AI meets unstoppable passion. Okay, this is where, not here. Where AI meet unstoppable passion, turning code, creativity, and courage into the legacy, teaching thousand to master AI one video at a time. Not just a creator, mentor, visionary, and a job maker. Don't chase opportunity, build them. Right. So this is the like a small text which I written. Right. Now over here you can see how the data will be created. Right. For this non-instructional fine-tuning. Non-instructional fine-tuning. Okay, so let's suppose this particular data you got from any PDF, right? So let's suppose you got this particular data from any PDF. Now how the data will be created for the non-instructional fine-tuning, right? Non-instructional fine-tuning. Now see, Sunny would be there, so Savita would be the output. Sunny Savita will be the input. Now this particular character will be the output. You can clean the data. See, later on I clean the data, so that's why this character is not there. Sunny Savita would be there, then where would be the output? Sunny Savita, where will be the input? AI will be the output. Sunny Savita, where will be the input? Meets will be the output. Sunny Savita, where AI meet, so this is the output. Sunny Savita, where AI meets unstoppable, so passion will be the output. Sunny Savita, where AI meets unstoppable passion, right? So this turning will be the output. Now guys, here you can see how we are preparing a data. So we are preparing a data in such a way so that we can predict the next token. Okay, next token means we got a model. Okay, base model. Now let's say if I want to be train this base model on our own data, on our own text data, this text data in a PDF, this text data belong to any specific domain, right? So what I'll do, I'll prepare my data in such a way, in this particular way. Now guys, what is this? This data actually, it is representing to the self-supervised training only, self-supervised learning only. Okay, we have performed the unsupervised pre-training. Let's say I got one general knowledge based model. Now if I want to be trained for my own industry specific data, I can follow this step, and this is called the non-instructional fine-tuning. The data could be available in a PDF. We can get a text, we can again retrain the model, and we'll be getting a domain specific model, right? I hope this is clear. I'll show you with the practical, this entire thing, even the instruction fine-tuning and the RLHF, means the DPU technique. Okay, on the same model guys, right? Now let's see the instruction fine-tuning. So guys, in the instruction fine-tuning, right, which is again part of the SFT itself. So dataset follow instruction in the response format. Okay, don't worry, I'll show you that how it looks like, because I kept each and every type of data, right? From the Hugging Face itself, I kept the several data. So non-instructional fine-tune data, then instruction fine-tune data set, then preference alignment tuning data set. So this data set I just kept to show you how the data could be look like. Okay, the instruction fine-tune data and the normal data, and then the preference alignment data. Now here, so the data set follow instruction in the response format. What is the use case? The use case to build a chatbot, because the chatbot we required the model which can do the human conversation, human-like conversational. Okay, so for building a chatbot, or I can say for building the conversational AI, we always require the instruction fine-tuning on top of the LLM. So let's say we have a base LLM. Now this base LLM for performing the conversational, for building a conversational AI or to build a chatbot, what we'll do the instruction fine-tuning. This is pretty much important. Now in between, even though we are again training this base model on some domain specific data with some domain, with this domain this base LLM on some domain specific data with the non-instructional fine-tune, okay, with the non-instructional fine-tuning data, right? But if I want to convert my model into chatbot, in the conversational AI, into the QA system, right, that definitely we require this instruction fine tuning. Now goal to teach the model to the human based instruction, right? Human like conversation. Now output style, so direct, helpful, and structure answer, more reasoning based answer. ChatGPT is the best example of it. They did the instruction fine tuning of the base model. They didn't did the they did the unsupervised pre-training on a very huge amount of data. They taught the model to the general knowledge and all, and then they perform the instruction fine tuning. But this stage is for us, for you and me, for a specific company, guys. Okay, if I want to avoid this particular step, okay, if I don't want to train my base LLM, if I want to pick my base LLM, if I want to do the domain specific tuning, so this step is for me. And if I want to convert my model, okay, into the conversational model, then this particular stage is required anyhow. Now what is the data example? So see, this is the data example which I mentioned. So here would be the instruction example, what mitochondria does in one sentence. Now see, mitochondria generate energy for the cell through the respiration. Okay, so we asked the question in this for this specific answer, and it has generated this specific answer, right? If I don't want to generate any extra thing, any other thing, that's why this particular fine tuning is required, right? Now meaning the model learns produce direct question answer, okay, and it learns how to generate the structure answer based on the given instruction, based on the given question. Now common data set, so these are the common data set which you can see over the Hugging Face itself. I'll show you in some time. Now how ChatGPT have performed the instruction fine tuning, on which data they have done. So they have done on the Reddit conversation, on the QLoRA, on the Stack Overflow conversation, Stack Exchange conversation, right? GitHub issues discussion, right? Open forum and the community board like Hugging Face, Kaggle. I'm just saying with respect to the coding as of now, but yeah, it could be any open forum, community forum and all. Okay, so like the in the comment itself we are doing a discussion with respect to any specific post, right? So that data also could be possible, right? So ChatGPT, the OpenAI picked this particular data for the instruction fine tuning of the ChatGPT model, of the GPT model, which have been used under the ChatGPT application. Okay, now guys, what is a combo? Means if we are going to train our own model, so what could be the strategy? The strategy could be, first we can do the normal fine tuning, okay, to adapt the model on your specific domain. And after that, what we can do? So first we can do the normal fine tuning, and after that we can do the instructional fine tuning. Okay, and with this particular strategy, my model will become the beast. Means my model can generate an output according to our requirement. Okay, now the last step is called the alignment with the human feedback. So for that, so here you will find out data. So in which way the data will be available. So pair of response ranked by the human. Okay, means human is ranking the response, whether it's good or not, whether it's a positive, negative, something like that. Now for that we have RLHF technique, DPO technique, RLAIF technique. But guys, this technique is a very basic and useful, so we'll go with this particular technique. But when I will explain DPO in the detail, definitely I'll give you the glimpse of this technique as well. Okay, this technique RLHF and this RLAIF, reinforcement learning from the AI feedback, I'll discuss about this as well. Now what is the goal of it? To make the model polite, safe, helpful, and aligned with the human value. Now LLM has generated an answer, that's fine, but human is liking this answer or not. Okay, human is liking this particular answer or not, we don't know about it, right? So what we'll do, we'll again perform the training. Using this DPO technique. Again, it's a supervised training only, and I will show you how the data looks like. So I kept some of example over here. GPT-4, pre-trained GPT, supervised fine tuning. Okay, with the there's a instructional fine tuning, and then RLHF. Gemini also SFT, RLHF, and then multimodal alignment. Okay, DeepSeek also they have trained in the same way. Okay, all the steps they have followed. Now ChatGPT, right? For the GPT, how they have collected this human feedback data. So they have collected from the log, okay, from the ChatGPT user log, means whatever answer is being generated, whether a user is giving thumbs up or thumbs down. Okay, so that particular log they were capturing, and that was a data, right? So collected with the user consent and anonymization. Okay, so whatever user is giving the feedback, okay, based on that, that particular data they have filtered, okay, and again on top of that data they have retrained the model, right? So likewise they have captured the data for the chat gpt, for building the chat gpt, okay, for training the gpt model on the human feedback. Now this particular example I kept for the GPT model itself, for the chat GPT. But in our case, we'll have to collect our own data if we are going to build a chatbot like this, okay, on our own LLM, right? So I hope guys this thing is also clear. Now let's see some family wise breakdown, Llama, Gemini and all, and then basically I will go with the different data set. And first we'll start with the non-instructional fine tuning, okay, and in the next video I will show you the instructional fine tuning. So here I kept the family-wise breakdown, means I kept the different family of the model like Llama, GPT, Mistral, DeepSeek and Gemini. So let's look into all these three stage of the training with respect to these model. So stage one, let's say Llama, pre-train on trillions of token. The data would be the common crawl data, books, coding and all. Then in the next stage, we perform the SFT, supervised fine tuning. So we have made this Llama to chat. If we want to make it to the human, if we want to align with the human responses, right? So we did the third, we have performed the third stage, okay. Then public wise, so Meta release both base and the chat variant, right? So you can choose base or chat. The chat model basically it's aligned already, okay. Means they have performed the instruction fine tuning as well as they have aligned with the human feedback. Now if talking about the GPT, so GPT-3 which was released in 2020, it is a pre-trained model only. Then Instruct GPT they have released in 21. You can check out with this particular model. They have performed the SFT, means instructional fine tuning as well as the RLHF. Then in 2022 and 23 they have released the GPT 3.5 and 4, heavily aligned with the RLHF and safety filters, okay. And again it was an instruction fine-tuned model. Then GPT model are closed source, so you don't get base bait over here, means you cannot get this particular model because it is closed source. They are just giving the API, directly use the model. If you want to fine tune on your own data, if you want to perform the instructional fine tune, that is possible, okay. I'll discuss that. Now Mistral wise, same thing. So Mistral 7B is a base model. This particular model was released in 23. Then 8x7b model, this is a mixture of expert, again it's a base model which again released in 23 itself. Then instruction version of the model, this model was released, you can check out with the repository of the Mistral. Then some model also aligned with the RLHF and DPO, okay, you will get inside the repository itself. Open weight released means we can also use the base model as well as the instruct model directly, and we can fine tune for our own requirement, okay. DeepSeek again in a same way. So they have released the base model, pre-trained model, okay, in all the variants. Then they have released the DeepSeek code model, okay, which is trained on the code data. It was the SFT training. Maybe it was the instruction fine-tuning training. Then they have released the R1, okay, this was again aligned with the human feedback, right? Now open weights is available. It is a China's big open source push. For sure you can download this model from the Hugging Face itself. Gemini again same thing, right? So this was the family wise breakdown guys, and similar to that you will get the cloud based model, right? Opus, Sonnet and all, and yes, they have also trained in the same manner. So unsupervised pre-training, then domain specific fine tuning, non-instructional, then specific fine tuning, instruction fine tuning, and then RLHF. Okay, these are 4 stages. Let me revise all this thing over here. First is what? So first is the unsupervised pre-training, okay, unsupervised pre-training, UFT. The second is SFT, supervised fine-tuning, again 2 part of it. Non-instructional fine-tuning data on this data, and then instructional fine-tune data. Then third is reinforcement, preference alignment, preference based learning on human feedback, okay, on human feedback. Now we're talking about the GPT model, the chat GPT product you are seeing, okay, or any other product which have been released by any other company. So they have performed the unsupervised pre-training, then they have performed the supervised fine-tuning, means instruction fine-tuning, and then this preference based alignment. Now if you are doing for our own company, our own company, so we cannot, okay, if we are doing for our own company, so we cannot train the model from scratch. It is not possible. So what we'll do, we'll pick the base model, we will train it on our non-instructional fine-tuned data. If I want a structure output, in that case I will go ahead with the instruction fine-tuning. Okay, first this, then this, then this, and then if I want to be aligned with the human answers, then I will perform the preference based alignment, okay, through the human feedback. Okay, so here I will go ahead with the DPO technique, right? So this is the entire summary of this theory. Now we'll see the practical, guys. Now for the practical, guys, I created Google Colab notebook, and you can see the title of the notebook: non-instruction pre-trained LLM fine-tuning on a domain specific data set. Okay, so let's connect to the GPU. Now here you need to change to the runtime. If you haven't changed, then change to the GPU and then save it. You can purchase the Google Colab Pro if you want some premium GPUs like A100 L4 GPUs. Okay, you can work with it after purchasing the Google Colab Pro. I don't have Google Colab Pro right now, so that's why I'm working with the free GPU itself. So I written the title, I connected with my GPU. Now let's start with the practical. Now first of all, guys, let me show you the data set. So here is my data set. So this data set is belong to the pharma domain. Okay, this is the dummy data set. Here I just have one page because I just have to show you how to fine tune our model, how to fine tune our pre-trained model on top of the domain specific data set, which can reside in any PDF, any document. Okay, so this is the plain text only. You can see here we don't have any sort of a CSV, we don't have any sort of a column right now. Okay, we just have plain text. So we'll transform this particular data, okay, into the appropriate format, and then we'll pass it to the model. So this is our main aim. Now here for performing the practical, guys, I am going to use the Hugging Face. So let me show you the library, what a library we're gonna use for training. So here, guys, we are going to use transformer library. We're gonna use the dataset library. Okay, then accelerate we are not using because this library is for the multi GPU setup, but yeah, we'll install it because some dependency onto this accelerate. Then we'll use the bits and bytes. Okay, this is for the loading the quantized model. Then PEF library, it is for the LoRa configuration, right? So LoRa, prefix tuning, adapter, everything we can do using this PEF library. Now you can see the further detail of this library. So who has created this library? Hugging Face only created this transformer library. Same dataset library been created by the Hugging Face. Then accelerate library also created by the Hugging Face. This bits and bytes library is created by this specific guy, Tim Determers. So this library is available under the Hugging Face. Okay, this bits and bytes, you can directly install it from the Hugging Face itself. Now PEF library, it is also created by the Hugging Face. Okay. Now the key research paper, GitHub and all, you can search because it is an image, or else what I will do, I will give you in the description, you can take from there itself. Now after that, guys, what we have to do, we have to install all this library. So for installing this library, this is the command: pip install -u peft bits and bytes transformer and accelerate. Okay, now guys, after installing it, I required one more library. So the next library is the TRL. Okay, this TRL, the full form of this TRL is Transformer Reinforcement Learning. So for performing the supervised fine tuning, we required this TRL library. So let me install this also. Now we required one more library. So we required this PyMu PDF because my data is residing into the PDF. Okay, so we have to load the entire data from the PDF, and for that we required this PyMu PDF library. Okay. So I hope till here everything is fine, everything is clear. Now first of all, guys, let me show you how the different data looks like. Okay, so what I'm doing, guys, I am going to copy and paste the different dataset link over here. So first let me show you this non-instruction fine-tuning dataset. So this dataset, actually it's a pre-built dataset, means already you will find out this dataset over the Hugging Face. So you can look into these dataset, and if you want to use this particular dataset just for the practice, okay, or just to train any model, you can directly take it from there. Okay, this is a pre-built data set which you will get from the Hugging Face itself. But guys, in our case, we are going to fine tune on our own custom data. So this data set is not available over the Hugging Face, means this is the or we are assuming that this is our own enterprise data. This is our own company specific data. This is our own customized data. Okay, so we are going to be loaded from the PDF. But already over the Hugging Face, you will find out so many data set, non-instructional fine-tuning data set, instruction fine-tuning data set, and even the DPO data set. So what I'm doing, I'm keeping some name over here. So here, see guys, these names belong to the non-instruction fine-tuning data set. Okay, now likewise, I can give you the instruction fine-tuning data set so that later on you can go through with it. So here is the link of it. Okay, directly I kept the link of the instruction fine-tuning. I kept it in my notebook, that's why I'm directly copy and pasting from there only. Then I have one more type of data set, that is preference alignment data set. Okay, so let me show you that particular data set also. So here is the preference alignment data set. So if I'm going to show you, see, let me show you the data set, how it looks like. If I'm going to show you this fine web data set, okay, I already opened this link. See, this is the data set. It is available under this Hugging Face FW repository. The data set name is Fine Web. Okay, so see, inside this particular data you will find out this text column. So entire data has been divided into the multiple rows. Okay, and it is available under this text, means the entire plain text. Okay, it has been divided like this. So we have to prepare our own data. Okay, this customized we have to prepare our own data, this PDF data, into the same format. So let me show you the PDF data. See, this is the PDF data. No? It is a plain text, right? So this was also the plain text, but this particular data have been prepared like this to feed to the model. Okay, so we have to prepare our data, PDF data, into the same form. Now let me show you the another data. So this is one more data, the pile PubMed abstract refined by data user. So guys, this is this data set actually belong to the pharma research paper. Okay, now here inside this text column you will find out the abstract of all the research paper, right, inside this particular column. Now this particular data is refined by this library, data user library. Here you can see this data user library, which is used to pre-process the data. Okay, that's why the name is like this. The name is the pile PubMed abstract refined by data user. Now see, inside this table you will find out this text column, and under this text column you will find out the entire data into the multiple rows. Now the other column actually it belongs to the metadata, so you can ignore this particular column. Now while we are creating the data, at that time you will get this particular column, but yeah, you can create this particular column, but again there is no use of it. The main use of this text column only. Now let me show you one more data. See, here is one more data, sky line. So inside this repository, sky line 007, under this repository you will get this open web text data. So this data set, see here you can read out the definition of this data. This is the open source replication of the web text dataset from the OpenAI, means whatever dataset have been used by the OpenAI, it is a replication of that. Now this dataset is very huge. Okay, this dataset was used to train the GPT-2 model. Now here you can see the size of the dataset. So total size of the dataset is 55.21 GB. It's very huge dataset, guys. Now here you can see the example. So under this text column only, the data will be residing into the multiple chunks, into the multiple rows. Okay, so there could be a tabular format, or you can look into the means the data they can show you into the JSON format. Okay, but the column name would be the same, text only. Okay, so we have to prepare our own data in a same format. Now let me show you the other data set. So here I can open that data set. Where is the file? So here is a file, guys. So what I'm doing, guys, I'm going to be open the other data set. Let me close it. Step by step I can open. Okay, so guys, here in the instruction fine-tuning data set, I'm going to be open this particular data. The data set name is what? Mental Health Counseling Conversation. Now this is the instruction fine-tuning data set. Now here you will find out the context, okay, and the responses. So this is the question, right, and here is the response of it. So the data you will find out in the form of instruction and the responses. Okay, so you can think in such a way: this is the input, this is the output. Okay, this is the question, this is the answer, this is the instruction, this is the response, this is the context, this is the response, anything you can say. Now I can show you the other data. See, this is the next data, alpaca, this clean data. Now inside this data set also you will find out this output, instruction. Okay, output, instruction. Input column is empty over here. Okay, Now you can look into the other data set. See, open ORCA data. So inside this particular data also, what you will get, guys, you will get this system prompt, question, and the response, right? So in every instruction fine tuning, in every instruction data set, okay, in every instruction fine tuning data set, you will get the question as well as the response of it. Now I can show you the preference alignment data. Okay, so this particular data was created by the Anthropic, public by the Anthropic, just for the practice, or like how the DPO, how the this preference alignment data looks like. Now inside this particular data, you will find out two columns. First is a chosen, so whatever answer is chosen by the AI, and the rejected. Okay, whatever answer is rejected by the AI. Now I can show you from the different repository. See, here is from the different repository, so you can you can check this ultra feedback binarized preference clean. So inside this particular repository also, you will get two columns. One is prompt and second is chosen. Okay, and then another column you will get rejected. Okay, so chosen and rejected, this will be the common column in every preference alignment tuning data set. So you can look into the other data set. See, let me show you the last one also. So here is the last one. So guys, inside this particular data also, you will find out the prompt, initially region step, chosen, and then there will be one more column, rejected column. Okay, so guys, in every data set, right, which is belong to the preference alignment, you will get the chosen as well as the rejected. Now I hope you got to know how the non-instructional data, instruction data, and the preference alignment data looks like. Now this data set is already given by the Hugging Face. Okay, so this is the pre-built data set, right? But guys, we are not just doing the practice using this pre-built data set. Many YouTubers, on many YouTube video, you will find out this kind of tutorial. So we are doing on our own custom data set. So in this particular video, I will show you with the non-instructional data. Okay, so this non-instructional data, this text column, we are going to be create from our PDF or data itself. This is our PDF data. Okay, now in the next video, I will show you the instruction fine tuning on a same data. Means we'll create instruction data set from the same domain. Okay, from the same kind of context to make our model more better, and then the same model will train on this preference alignment data. Okay, in the next video, I will create one preference alignment data. Okay, and on top of that particular data, will train the same model. So we took the we are going to take the base model. So first we'll train on this non-instructional fine-tuning data set, which is our PDF. So here you can see this is my PDF. Okay, now after that we'll train on this instruction fine-tuning data set in the next video, and then in the next video we'll look into this preference alignment data. I hope now everything is clear. So let's start with the practical. So first of all, guys, what we'll have to do, we'll have to load our data set. Now before loading our own data set, the custom data set, let me show you the inbuilt data set. Okay, so how the inbuilt data set look like. So first let's load the pre-built data set. Now guys, I already written the code in the notepad, so I can directly copy and paste from there because this code is prepared by me itself. So first of all, we'll have to import the data set. Okay, so from the data set, guys, I am going to import two things. So let me import two things over here. The first thing is the load data set, and the second is the data set itself. Just a second, let me check what is happening. Okay, so guys, here I loaded this, here I imported this data set as well as this load data set. Now what we are doing, guys, so here you can see we are going to load this tiny story from this particular repository. Okay, this is the data set actually. Again, it is a non-instructional tuning data set. Okay, this one. So I can show you also. So I can just copy this particular name and I can paste it over here. Now here, see, you will get the very first link, right? So just go through with this link and see, here is a text column, only the text column. Okay, so this data set again have been divided into the multiple rows. Now what I'm doing, this is a pre-built data set, okay, from the Hugging Face. I just want to show you how the data set look like. So if I'm going to print this data set, so what I'm doing, I'm going to be right over here, print data set. Now see how the data set look like. So let me copy this data set, and this variable I am pasting over here. Okay, so this is my variable. Now see, so okay, first of all we'll have to load it. This loading might take time. Okay, it's loading. Fine. So see, the data is loaded. Okay, so guys, the data is loaded successfully. Now after that, what I'll do, I'll print the data set. See, here is a variable. Here is the data set variable. Now inside this data set you will get the feature, only one feature I have, and see the number of rows. So how many rows we have? We have 21,19,719 rows, means almost 2 million rows. Okay, so guys, but we are not going to use this data set. Instead of that, we'll create our own data set. So let me show you a couple of rows from here. So let's check with the first row. So here you will get the first row. See, this is the first row. Now let me show you the second row. Okay, so here is my second row, this one. Now if you want to check the last row of this data set, so simply you can write over here -1. See, here is the last row. Okay, so guys, this data set was a plain text, and now this data set was divided into the multiple chunks. Okay, multiple text chunk, and under this text column you can see the data. Okay, number of rows. Now we have to convert, okay, our PDF into the same format. If I want to train the model on top of the PDF, okay, so we'll have to convert into the same format. So how we can do it? So first of all, guys, we'll have to load the data. So for loading the data, let me write a heading. I will share this notebook. You can completely follow this notebook. Okay, I'll give the link in the description itself. So here is the basically custom data. Okay, so you can see the heading. Now what I'm doing, guys, I'm going to be import the feeds library. This is from the PyMu PDF itself, means in the backend it is using the PyMu PDF. This feeds library we use to load the PDF. Now here I've created one function. My function name is what? Extract text from the PDF. Okay, so I will give the PDF path. I will take the text. I will load the text inside this particular list. Okay, I will open the path. I will iterate on top of the pages. Okay, I will collect the data from here and I will append inside the list. Simple logic. Okay, and then I will return this particular list after completing the loading. So let me give the path. So here is my path, content formin.pdf. Now once I'll run it, guys, so what I'll be getting a data. So here it is saying the data is not available because first we'll have to upload the data. If you're not going to upload the data, guys, in that case you will get a same error. So please make sure that you are going to upload the data over here, or else you can read it from the GitHub, you can read it from the drive, anywhere you can keep this data and you can read it. Now what I'm doing, guys, so here let's try to read the data now. So see, I got the PDF text. I can show you how the text looks like. So this is the text, guys, the complete text which I am able to get from the PDF itself. Now after that, what I'll do, I will divide the text into the chunks. Now this divide the text into the chunk, it is a hyperparameter. Okay, so this logic, basically what we can do, this logic we can decide how we are going to be divide our data into the chunks. Okay, and what would be the size of the chunk, right? Now I can give you a couple of examples, so I kept for all of you. Now first of all, guys, see, whenever we are going to load the data. Okay, so this is the complete step which we need to follow. As of now my data was not too much, but if we are going to train our model from scratch, okay, or if we are going to do the non-instructional fine-tuning, so you need to follow the same step. So first you need to collect the data, which we have already done. So see, this is my data. Now after collecting the data, guys, what we have to do, we have to cleaning and filtering the data. Then we have to divide the data into the chunking, okay, multiple chunks, because we cannot give this entire data at the single go, right, to train my model. Then tokenization means we have to convert our data into the specific numerical ID, okay, after the chunking. So to every token into the given chunk, one numerical ID will be assigned, and then we are going to perform the training, which is the next token prediction, right? So this entire step we have to follow. Now guys, here I kept one more table. So this table could be very much important. So just try to read this particular table carefully. So here I given the model name, max context window, approx word, how many words could be there, and the comment, right? So GPT-1 model, so it was able to handle 512 token, and there was approx 350 words. Now GPT-2 1000 token, okay, around 750 words. GPT-3 2000 token, 1.5k words around. GPT 3.5 409k token, around 3k word. And if you're talking about GPT-4 40, so it is it is able to handle up to 1,28,000 token, around 1 lakh words. Okay, now over here, guys, you can see, so whenever we are going to chunk the data, okay, so we have to keep something in our mind, right? So our model, right, how much basically token can handle. and whenever we are going to be divide the data into the chunks, okay, so we can follow some regex pattern also, means we can divide our data into the paragraph, we can divide our data into the segment, okay, or a semantic chunk and all, and then basically we can or else basically we can go ahead with the token length also. So let's say if we are going to be train GPT-4 kind of model, so let's say we are going to be load the data, this PDF data, okay, so we can give the bigger chunk to the GPT-4 model to retrain it to the fine tuning it, okay, and similar at the time of the unsupervised tuning as well, okay, means the first step, the initial stage, okay. Now here guys you can see, so this chunking we can do based on what, based on this particular pattern. See here I written based on the paragraph, semantic chunking, right, we can write some regex rule and all, and then we can, or else we can go ahead with the token length, means how many tokens we can bear in the single chunk, according to that also we can define the chunk, or else we can take the both strategy, okay. So I written a function over here. Now see the function, so it's split paragraph. So first we'll take the pages, okay, this data. Now we are going to be split based on the line, okay, based on the new long line, means the double line. Here you can see in the PDF itself. So if you will look into the PDF, so where it went here, so here you can see between this line and this line we have major gap, right? So we are going to be divide our data into the based on this major line, okay. So this is the regex pattern, you can write any regex pattern, you can read out the chat GPT model research paper, any other research paper, right, how they have done the unsupervised pre-training, how they have divided the data into the chunks, the entire text and all, right. So it will also help you, okay, but this is also a generic practice. Then what I'm doing, I'm iterating on top of the chunk, and if I'm saying over here, if there is a 30 character, more than 30 character, then only I'm going to be append the chunk into this particular list, okay. So whatever pages we have these on, we are iterating on top of the data, okay, and on the entire list, then we are chunking based on this strategy. If inside this chunk we have more than 30 character, more than 30 character means what, 10 to 12 token, okay, or 8 to 9 token. So more than 30 character only, then only we are going to append inside this particular paragraph, okay. So if I will run it guys, now here you will see we are going to be split our data. So here inside this particular variable I'll get my data, split data. Now see, so see what I have the first chunk, then second chunk, okay, then third chunk, then here you can see the fourth chunk. But guys, the data should not be like this. The data should be available into this particular form, okay. We should have this okay, we should have this text column, and under this text column the chunk should be present. So what I'll do now, I will map my data, okay, to the text column, okay. Now here what I'm doing, I'm iterating on top of the chunk, and then I'm assigning it to this text column. So now how my data look like, so if I'll show you the data, so here see my data guys, we have this text, okay. Now with every text one chunk is associated, chunk text, okay. Now what I'll do, I will convert this particular data into the Hugging Face compatible data. So for that I have a dataset library, okay, which I already imported. Now from here I will call this from list, okay, from underscore list. Now from this list itself, so here you can see this is a list only now, right? So I will pass this data to the list, okay. And now what I'll do, I'll keep it inside the variable. Let's say my variable name is dataset, okay. Now see my Hugging Face compatible data is ready. So if I will show you this dataset, so how my dataset look like, see, feature text, okay. Under this text we have a multiple chunks, okay, and here number of rows is 4. So if you will look into the pre-built data guys, this was my pre-built data. If you will look into my pre-built data, so this was a pre-built data which I loaded from the Hugging Face. In a same way we are able to convert our data. See, here is my data. So now you can check the first row, second row, whatever row you can check. So let's say if I'm going to be check the first row, okay, I will simply put the 0. So here you will be able to get the first row. Likewise you can get the second row, okay. So in total we have 4th row. So guys, in whatever way I was having my pre-built data, the data was already available over the Hugging Face. Now I'm able to convert my data set into the same format, okay, my custom data set. So this all the technique, all the pre-processing step you will have to follow with respect to your plain text. Now coming to the next part. So the next thing is basically we have to select the model. So first of all, let me create the multiple cells, okay. Now here we'll have to select the model. So let me make a heading. So the heading is, let's select the model. So guys, model wise, what I'm doing, I'm going to be select a very tiny model because I cannot bear the large model inside with this particular GPU, with this particular memory. We require more VRAM and all. So if you have Google Colab Pro access, or you have more VRAM, then you can try out with this particular model. I'm using this model Tiny from the Tiny Llama repository. So Tiny Llama 1.1b intermediate step 1431K 3T. Okay. Now, what does it mean? What is the meaning of this line? So I written a meaning of this line over here. See, so the checkpoint is from the Tiny Llama model, okay, which trained up to 1.54 million step over 3 trillion tokens capture midway before the final conversion. So guys, this particular model is a Tiny Llama model. This model trained till this particular step, okay, around a 14 lakh step, okay, on top of this much of token. So I'm using this model to train. I'm using this as a base model. This is my base model, guys. Okay, this model is not being trained on any instruction data, or not on any domain specific data. This is my base model, simple pre-trained model. Okay, so I'm going to use this particular model to perform the domain specific fine tuning on top of my PDF data, right? I already prepare a data. Now what I'll do, guys, I will basically perform the fine tuning. So first of all, guys, what I'll do, I will load this specific library like auto tokenizer, auto causal LM, trainer, training argument, and data collector for language modeling. I think this will not be required. Training argument will be required. So let me run it, and I'm going to load the library. Now here, what I'll do, guys, I will load the tokenizer. Okay, I will tokenize my data because I already performed the chunking. Now I will perform the tokenization using this particular tokenizer. Okay, so I'm loading a tokenizer. Now after that, guys, I have to execute one more line of code. So if padding is none, then in that case I'm going to be assign this end of the token to the padding, right? Now why it is required, let me give you the reason of that as well. So here I kept one image, with that you can easily understand. So guys, what is a pad token? So pad token we use to make all sequence in a batch to the same length. So let's say in input word we have 2 token, hello world, right? In input 2 we have 3 token, good morning everyone. Technically there is a 3 token, hello world, this full stop, then good morning everyone, full stop. Now here you can see the size of the token, size of the input 1 and input 2 is different. So if I want to make it same, so here what I'll do, I will do the padding. Okay, now how I am going to do the padding? So at the end, okay, at the end of this particular see here, the length of this particular input is 4. Okay, 1 2 3 4. Now what I'll do, so here at the end of the sentence, hello world, okay, after this particular word I will add one more token, okay, that's going to be EOS, end of the token, okay, this EOS. So if I'm going to be append the EOS token, now how my sentence will look like, hello world EOS. Okay, so the length of this input 1 and input 2 is going to be same. So that's a simple use of this line. So let me run it, and here we are able to append this end of the token. Okay, now after that what I'll do, guys, so after that, guys, we are going to be pre-process the data. Now the pre-process step is pretty simple. So here we are passing example, means every text chunk. Now after taking every text chunk, see, we are truncating, okay, we are padding, and we are like defining the max length. So what is the meaning of this particular parameter? I'll tell you. Now here we have one very important line. So to token, okay, to the label, actually we are going to be assigned this input ID, okay, and then we are going to return the token. So let me execute it, and let me explain the meaning of this each and every line, because it is very much important. So here what I'm doing, guys, I'm going to be I'm going to be like add some example and all, and with this particular example we'll be able to understand. Now see, so whenever we are passing the text, so let's assume this is my text, okay, metformin improves insulin sensitivity in the liver. So what will happen? So this tokenizer token, okay, it is going to be take this particular text. Now truncation true, what it will do, so if the text is longer than 512 tokens, it is going to be cut off that. Padding true means if the text is shorter than 512 token, it's going to be pad. Okay, and the fixed length of this particular sentence of this like whenever we are doing the tokenization, it will be 512. Okay, if it's going to be less and more to this 512, then we are going to be truncate, or we are going to be perform the padding. So after processing it, I will be getting this particular input. So input, I will be getting this particular output, where I will be having 2 column input IDs, okay, which is going to be assigned to every token, and then attention mask. Attention mask is saying which token is important for me to the attention layer. Then label, guys, so token labels, token input ID dot copy. Now why we are doing it? So this is a key step for the causal unsupervised language modeling. Means what is our aim? The model should try to predict the next token in the same sequence. Okay, I shown you how the data is being prepared for this non-instructional fine-tuning. Okay, for this plain text, for this particular plain text. Okay, so we took this plain text, we convert into the text. Okay, multiple rows, we did the chunking because of the model, right? Because we cannot put the entire data in a single go to any model. Okay, and then we have to predict the next word. Okay, in the non-instructional fine-tuning, we are doing this self-supervised fine-tuning, self-supervised tuning itself, right? So what we have to do, we have to predict the next token, and for that what we have to do, we have to prepare a data in such a way. So here you can see the sentence. What is my sentence? Metformin improve insulin sensitivity in the liver. Now see over here, this is my input. Metformin improve insulin. Now what is the target level? Improve insulin sensitivity. So okay, so metformin improve insulin. So here what is the next word of it? So metformin improve insulin sensitivity. Okay, so the sensitivity will be picked as the next word. So this particular line, with this particular line, we are going to be prepare this kind of data. Okay, now whenever we are passing, whenever we are getting final result, so we'll be getting the input ID, attention mask, as well as the labels, right? So let me execute it and let me show you how the data looks like. So for executing, we'll have to map the data. So here what I'm doing, guys, I'm going to be map the data. So I have a data set, I'm calling .map, tokenization function is there. Batch 2 means we can pass the data into the batch if we have so many data, okay, so many rows. And here remove column text means in the final output, we just want this three thing: input ID, attention mask, and label. We don't want this text. Okay, so I'm going to remove it. Now here I will be getting my tokenized data. If you want to check it, you can simply check it. See, here is what? Here is my tokenized data. Input IDs, attention mask, and label. Now here is the number of row. Number of row is 4. Now what I'll do, guys, I will load my model. So here you can see I'm going to be load my model. So model loading might take some time because the model size is around 4 GB. Okay, so in your it depends on your internet speed. In my case, it might take like 4 to 5 minutes. So let it load, guys. So guys, my model is loaded. It took around 4 to 5 minutes. So as I told you, it depends on your internet speed also. Now after that, what I'll do, guys, I will define my training argument. Okay, so here inside the training argument, so guys, see, we have so many training argument inside this class. If you will see the list, you will get the hundreds of argument. So how you can get the detail of it? So for that, you can simply call this help training argument. Okay, so you already loaded this class from the transformer. You already imported this class from the transformer. Now simply pass it to the help method. Okay, now once you will run it, see here you will get the detail of each and every parameter, whatever is there. Now I mentioned the required parameter only, so I kept the meaning of this particular parameter. Let me mention it over here. So output directory means where we are going to save the model. Overwrite output directory means we are going to overwrite the previous model. If we are saving the new model, it will overwrite to the previous model. Number of training epochs, how many epochs we are running for the training the model. Per device train batch size means in one single go how many batch size we are passing. Save step, at which step we are saving the checkpoint. Save total limit. Okay, so keep how means how many checkpoints you want to be keep on your disk. Let's say you have five checkpoints, so you will keep only 4 and 5 checkpoint. If you are writing 2, okay, the latest 2 checkpoint you will keep on your disk. Then logging step, at which step you are going to be log. Okay, learning rate means it belong to the optimizer. So if we have very huge learning rate, my basically graph will go here and there. If we have like a small learning rate, then my graph will go smoother. So guys, if you know the basics of the deep learning, then I think you can understand the meaning of this learning rate. And now FP16 for the precision, right? In which precision basically we are going to be load the model. A report tool means we are not going to be log our data anywhere, okay, on any basically a tensor board or any bit and bias like dashboard, right, or anywhere. So we are just like keeping none. If you want to keep, like, we can remove this none, and we can keep our metrics as log and all on some different platform. Okay, by default you will get the bait and bias W and B platform, right? So this is the meaning of this parameter. I think you got to know. Let me run it. So my models will be available inside this particular directory. Now after that guys, what I'll do, so you can check with this help method. Now I'm going to be define my trainer. So after defining a trainer, okay, so see the trainer might take some time. So trainer is taking three things. One is model, second is data, okay, this tokenized data, and the third is a training argument. That's it guys. Now after training, after defining a trainer, I will just call the train method on top of it. So trainer is a class. We are going to initialize this particular class, and then we are calling this train method. So once we'll call this train method, now guys see what we'll get. Can anyone guess what I will get? So you can pause the video and you can give me the answer in the chat if you're watching till here. So if I'm going to be run it guys, see here I will be getting out of memory error. Now why I'm getting this out of memory error? Because guys, you haven't focused, because we are training the entire model. We are retraining the entire model over here. If you will check, see we are loading the model. We are not going to be select any. Basically last row, okay, or the initial row. We are not going to do any LoRA and QLoRA. We are simply retraining the weight of the entire model, and my machine is not capable to do that thing right now, and because of that I am getting this out of memory error. So what is the solution of it? So the solution of it is LoRA, okay, parameter efficient fine tuning. Now before the LoRA guys, let me show you the other method also. So here I written some sort of a description. So let me keep the description over here. Okay, so what is the description guys? So here we are not specifying anything, means this is the full fine tuning. Now we have two methods for the partial fine tuning. The first, freeze some layer and fine tune unfreeze layer, which is the old CNN method or BERT style method, right? The second is LoRA, append some external weight to the already trained pre-trained weight. So guys, I will show you this both method. Okay, I will more focus on the LoRA. I'm not going to explain you this freeze some layer and all. I will give you the code. I'll keep it over here, but I'm not going to explain because I already explained in my previous video. So if you will go and check, right? So let me show you in which all video I have shown you. If you will go and check with the playlist. So okay, this is running. So if you will go and check with my playlist, so just check out with this third video and the ninth video. Okay, in this both video I discuss about this particular technique, and even I shown you the practical also. Now guys, come back to this like solution. Now here what I'm doing, I'm going to be write a code. Okay, first I'm giving the code for this particular method for freezing the layer. You can try out from your end, okay, or else you can watch out those particular video, but this is not an appropriate method. There is some pros and cons. Maybe in the later video we'll discuss, because otherwise this video will be very longer. Now here, this is the code guys. So let's look into the code what we are doing over here. So first we are loading a model, okay, then we are freezing some layer, then we are unfreezing the last 4 layer, okay, and then we are loading the data set, then we are defining the training argument, and then we are training the model. Simple guys, okay, that's it, nothing else. So you can look into this particular method and you can run it, but this is not an efficient one with respect to the larger LLM. We'll discuss theoretically later on why it is not. I'll show you the mathematics of the LoRA, DPO, everything guys, don't worry, right, in the upcoming session. Now what I'm doing guys, so here we are going to perform the LoRA based technique. So how to do the LoRA based technique, let's come to that. Now before running the LoRA based technique, I will run the garbage collector. Okay, so whatever cache memory and all will be there, unnecessary memory, it's going to be removed that. Now again what I'm doing guys, I'm going to be update the library, because before running the LoRA configuration, we'll have to update the libraries, okay. Because initially we haven't installed this PEP library, right? Bits and bytes, we also require the upgraded version, transformer, and the accelerator else also. So let me run it, let me execute it. Now after that what I'll do guys, I will import this particular statement. But before that guys, what you can do, you can simply restart the session, okay, because restart the session basically will load the latest version, okay, whatever version we require. Now after that what I'll do, I will import these packages, all the packages, auto tokenizer, causer LLM, training argument, trainer, then LoRA config, get PEFT model, task type from the PEFT, and then from the dataset we are going to load the load dataset, okay. Now after that guys, what I'll do, I'll take a same model which I was taking initially. Now here I will load the or tokenizer in a same way, okay. Then I'm going to be assign this US token at the end of the as a pad token, okay. So let me execute this. Now here it's the same thing. We are going to be map the data set. Okay. Now which data set guys we are using? We are going to use the same data set. So here let's see the data is available or not. If not, okay, the data is available. Now what I'll do, I'll load it again because I restarted the session. So I will lose my data. Okay, I will lose the variable basically. So where is my data? Now first of all I will import this import a statement. Now feeds extract data. Okay, this is fine. Now PDF, this is perfect. Regular expression, this is also correct. Paragraph is there. Data, okay, data. Now data set is ready. Okay, so guys, here what I'll get, I will get my data set. So let it run, let it execute, and what I'll do after that, I will again tokenize. So guys, you need to rerun this step, restart the session, because you might get some issue with the LoRa configuration and all. That's why restart the session. So let me check. Okay, now it is done. So here I got my data set. So where is the data? Okay, so tokenizer is running. Let it execute. Okay, so here guys, it is connecting. Okay. So let it connect, or else what I can do, I can disconnect and delete the runtime. Again I can connect. Okay. Okay, fine. Now it is done. So this is fine. It's loading. This is fine. Guys, it might take time. First time now it takes time. Okay. LoRa config get peft model. This is a like huge library. Okay, so the library is loaded. Now what I'll do, I'll load the model, then tokenizer. Now here I'm going to append the EOS token. Now this is my tokenizer function. So let it run. Okay, reconnect. Why it is disconnecting every time? Connected. Tokenizer is there. Okay, this is required. Don't know why it is reconnecting. Okay, so guys, I followed the same step and I got my tokenized data. So inside this tokenized data, as you know, we will be getting the input, attention, mask, and label. You can include this text column or you can exclude. It's up to you, right? So you can pass along with the text column, as well as you can exclude it also. You know how to do that. So I got the tokenized. Now after that, what I'll do, so here after getting a tokenized, guys, I will load the model. Okay, now this time guys, you can see we are going to load the model in the 8-bit format. Okay, so here I'm giving the model, then loading a model in 8-bit, and then device map is auto. Now it is saying bits and bytes require the latest version. So yes, we'll have to install it. That's what I was saying. Just a second guys, let me execute it. Pip install -u. Okay, so this is done. If it is giving you this particular warning, then please if it is giving you this particular error, then please install the latest version. Now this is done. So yes, this is fine. Now what it is saying, okay, fine guys, let me restart the session. So restarting a session, this issue you will get in a collab, okay, while you are working with this library. Now let me execute it. Okay, auto causal LLM is not defined, so here is fine. Okay, so guys, my model is ready and my data is also ready. Everything is done. Now here, see guys, we have loaded the quantized model. Let me write over here, loaded the quantized model, right? Now what I'll do, I'll define my LoRa configuration. So guys, we'll understand this configuration in a very detail in the upcoming session. So what is the meaning of the task type? So task type is a causal LM, means we are doing the next word prediction. Rn means rank, okay, rank of the matrix. Rolla alpha, so this is again hyperparameter. Target module Q and V, so this is related to the attention layer, okay, QKV. So Q query and V means value, so we are targeting to this particular module. Now LoRa dropout 0.05, bias is none. So we'll understand all this parameter in a very detail. So here you can see the complete list of it. It's a very huge number of parameter, but until we are not getting the mathematics of it, until we are not understanding the mathematics of it, will not be able to get the complete one. So definitely I'll show you in the upcoming session. So here I define the LoRa configuration. Now what I'll do, I'll load the parameter efficient model. Okay, get PEFT model. I'll give the model. I'll give the LoRa configuration. So this model is going to be my quantize LoRa model. Okay, quantize underscore LoRa underscore model. So yes, model is getting loaded. Let me define the LoRa configuration and see the model is getting loaded. So it's saying model. Okay, let me check what I have inside this model. Okay, so this should not be the case. Just a second, let me load it again. Actually we should get the model. I think I run that model string again, that's why it's coming like this. Okay, we should have the actual model over here. So yeah, this is the case. Just a second, because I already loaded the model now, so it will not take much time. Okay, done. Now see, this is my model, right? So here if I'm going to load it, so I'll be getting the QLoRA model. Now my training argument would be the same one. Then I have the trainer, right? So let me define the trainer. So here what I'll do, I'll give my QLoRA model. Okay, then argument, then tokenize is the data set. Let me check with this particular variable. Tokenize is correct. Now once I'll run it, so my trainer will be ready. Now what I'll do guys, I will train my model. So tokenize is not defined. Tokenize. Okay, this is my tokenize. So if I'm going to execute it, my tokenize is ready. Now what I'll do guys, I will run it and my trainer is ready. Now this time I will not get any error, because what we are doing, we are going to do the LoRa based training. So if I'll do this trainer.train, my model will be trained guys. Okay, so see, I have a very less data and we are doing LoRa training, so that's why it's not taking much time, and we are just doing for the 2 epoch. So see, the training loss is here, and you can see the other metadata. So see, the training loss is 9.66. You can run it for the more data and for the multiple epochs, but that is not a case right now. Means we are not running, we are not learning that how to reduce, how to improve the accuracy and all. That will be the different thing. So for that also I will create one session, but as of now we have to learn how to train the model at least, right? So my model is trained. Now after that I can get it, I can get my model over here. See, tiny llama LoRa, and under this particular folder my model is available inside this checkpoint, right? So what I'll do, I'll copy the path, and this particular path I'll keep it inside the double quote, and this is going to be my model path. Now what I'll do guys, tell me, after training the model I'll do the prediction, right? So let me do the prediction with this particular model. Now first of all guys, what I'll do, I will load the model. Now I'm going to load the model. So here is my trained model. Okay, trained underscore model, trained on the domain specific data. So let me execute it and see, my trained model is loaded. Now what I'll do, I'll give any sort of a prompt to this model. Let's say my prompt is clinical trial demonstrate that combine atrovestine with as a TIMBY, right? Something like that, right? I took it from this particular data. I don't have the domain specific knowledge, but I kept this prompt from this data itself. See here, from this data. Okay, you can check out with the different other data. Now what I'll do, I will perform the tokenization of this data. I already have a tokenizer, so here I will perform the tokenization. Now what I'll do, I'll get a output. So here model.generate. Now which model? Trained model. Okay, So train model.generate input, max token this much, temperature, top speed, do sample, repetition penalty. So these are all the parameter which we can pass, but you just need to focus on this input. Now once I'll run it guys, I will be getting my output. Now here I'm going to print my output. So let me decode my output, and tokenizer dot decode, and I'm giving the output over here, skip special token. I'm going to be skip that. Now let's see the output. So guys, see, this is the output. Critical tries demonstrate that combining episode with this is that, right? So guys, here what we have done, we have performed the non-instructional pre-train LLM fine-tuning. Means we took the pre-trained LLM and on top of our domain specific data, we have performed the fine-tuning, and we are able to get the very amazing result. But guys, here let's say if we are asking any sort of a question and my model is not able to generate that particular answer in that tone, specific structure, for that what we will do, we will do the structure fine-tuning, instruction fine-tuning, right? So now on top of the same model, in the next session I will show you the instruction fine-tuning, so that we can ask the question, right? More structured question, it can generate the answer according to that. So yeah, this is it for this particular video guys. Thank you, bye bye, take care. I'll see you in the next video. Thank you.